So let's start with the question, what is a beam splitter? So a beam splitter is a device that performs specific operations on light. And I'll be getting into a little more detail on later on what these specific operations are. But why should we care about beam splitters? Beam splitters have a lot of applications. They have applications in quantum computing. In photonic quantum computing, they can be used as Hadamard gates. They have applications in demonstrating indistinguishable photons through the Hong-Mandel effect. They're used in quantum networks and in distributed quantum computing to perform Bell state measurements. They're also used in quantum secure communication protocols like BBM92 as passive switches. And lastly, beam splitters can be a great generalizable model that can help to model processes like quantum frequency conversion or transduction. So we can kind of abstract the beam splitter and use that to understand other quantum optics processes. So what does a beam splitter look like physically? So there's different types of beam splitters. There's fiber-based beam splitters, there's free space beam splitters. For free space beam splitters, there's, again, different types of beam splitters. And I've included a couple pictures of some examples, but there's plate beam splitters and pellicle beam splitters. So we have an example of a plate beam splitter on the screen that has this 1 inch, showing kind of how large it can be. And we also have, in free space, these cube beam splitters. And these physically consist of 2 glass triangular prisms that are glued together with a glue or resin in between the 2 glass triangular prisms. And we'll get into later what the significance is of this kind of makeup of the cube-based beam splitter in particular. But basically, these glass triangular prisms are made out of a higher index of refraction material, and the resin or glue is a lower index of refraction material. Remember that the index of refraction of light will tell you the speed of light in the material, and it will also tell you some other properties of how light is going to interact with the material. So other than free space beam splitters, we also have fiber-based beam splitters. And these, again, come in different forms. But in general, the main difference is now the light is going to enter the beam splitter through a fiber. And the beam splitting part of this fiber-based beam splitter is within an integrated photonic circuit.